Welcome. All right, so what I'd like to do is show you how to verify this identity. And to do identity like this, we need to kind of decide of what side we're going to want to work on. And usually I say if you have a rational side, try to simplify that side. But you can see here we have rational expression on the left side and on the right side. And we also have a subtraction here and addition here. And it's like, well, which one's easiest? They both contain both things that we look for as far as which side to identify. So you can really try to pick and determine which side you want to do and see how far you can get. But another rule that we want to look to is always try to get monomial denominators. So you see in this case we have just one trigonometric term, so that's a monomial. But here we have two, which is a binomial. So a binomial. So to get that to be a monomial denominator, that's what I'm going to want to achieve first. So to do that, I can multiply this by cosecant of theta plus cotangent of theta, which is its conjugate. I got to make sure I multiply that on the top and the bottom to produce equivalent fractions. All right. Now when I multiply this across, this is obviously a difference of two squares, so I only need to multiply my first two terms and the last two terms. So therefore, now I'm left with cosecant of theta plus cotangent of theta, all divided by cosecant of theta squared, cosecant squared of theta minus cotangent squared of theta. All right. So now the next thing we want to do is let's see, well, how can we kind of still simplify this? Because you might look at this and say, well, you try to convert this to a binomial, and it's still a monomial. It's just one now squared. But what's nice about this is now I've converted this to squared trigonometric terms. And when I have squared trigonometric terms, I can use my Pythagorean identities. And also what's nice about this is we know that cotangent and cosecant are related in their Pythagorean identities as 1 plus cotangent squared of theta equals cosecant squared of theta. So now what I can do in this case is subtract. I guess I could just rewrite this. I could solve for cosecant and plug that in there. But that means I'm going to have to distribute the 1, and I really don't want to do that. So I'll just subtract the 1 here. So therefore, I know that cotangent squared of theta equals cosecant squared of theta minus 1. So now I know that cotangent squared, what am I doing? No, why don't I write that in there? It's already there. Let's just leave it like that. Sorry about that. I'm like having that fight with my brain. I already know cosecant squared of theta equals 1 plus cotangent squared. So what I'm going to do is rewrite this problem. And now I'm going to rewrite cosecant squared of theta as 1 plus cotangent squared of theta. And that's going to be minus cotangent squared of theta. Well, what we can see now is these cotangents are now going to divide out. And that's just going to leave me with the number 1. So by leaving me with the number 1, I'm just left with cosecant of theta plus cotangent of theta over 1, which is just going to be cosecant of theta plus cotangent theta. But now that still doesn't look like this, and now it's not even rational anymore. But what's nice about this is you notice here's its cosecant of theta, cotangent theta. This is in terms of cosine and sine. So therefore, what I'll do is I'll go ahead and rewrite this in terms of cosine and sine. So this is cosecant is 1 over sine plus cotangent is cosine of theta, that's over theta as well, over sine of theta. Now, since these have the same denominator, I can combine them, and therefore I'll just leave 1 plus cosine of theta all over sine of theta. And there you go, ladies and gentlemen. You can see that now they are equivalent to each other, and that is our final works. Thanks.